those failures could have an external cost and they could have an internal cost. So what we have given here is the quality cost is equal to the cost of quality control plus the failure costs, and the quality control cost is prevention cost and appraisal cost, and the failure cost itself is internal failure and external failure costs. Now if we look at it diagrammatically, if we have this as our quality level and we look at the cost on this side, we have something called the failure cost. The failure cost will keep decreasing as the quality level increases, and finally we'll have a situation where we have zero defects. Whereas the prevention and appraisal cost will keep increasing as we move towards this goal of zero defects. Now it is up to us to decide what is the level of quality that we will keep. What is the level of quality that is acceptable to us, because there is a cost involved. Now in the discussion so far, we've already talked about construction safety. Do you see some parallels between construction safety and construction quality? At least I see several things which are quite in common. When we talked of safety, we talked of prevention of accidents and we talked of the cost of safety. Direct cost, indirect cost, accident having a direct cost and an indirect cost. Then also there was the whole department of safety. There also we talked about a safety engineer, we talked about a safety audit team and so on. Those people were also involved in ensuring that the project site is a safe place to work. That is, there are few accidents. In fact, the target is zero accidents. Now, in order to ensure that, there is a cost that is involved, and much like in the case of quality control, there will be quality inspectors, there will be quality audits, there will be quality reports, there will be a feedback mechanism, there have to be records. Both quality and safety inspectors are not mainline execution people. They can be looked upon as people who hinder the progress. So quality control inspector can well say that, well, the product being made or the construction activity that being carried out does not meet quality standards, does not meet acceptable standards, and therefore must be stopped. Much as the safety inspector can say that safe practices are not being followed at site and therefore work must stop. But what has to be understood by the top management or the management of the site is that both of them are an integral part of ensuring a good product at the end of the day. They are part of a team that ensures the reputation of the company and the fact that finally the project or the constructed facility meets standards. So that's how we can kind of see the relationship between quality and safety. That of course is an aside. Now let us come to specific situations for a construction project. In this module, we will not be talking so much about total quality control or total quality management, zero defects and so on from a theoretical perspective, but the effort will be to identify certain small topics taken from the field of construction, taken from the site, and discussing them from the point of view of safety. So what we are trying to look at from a construction project perspective is quality of materials, components and systems. That's one way to look at it. The other way of looking at it is to talk of quality of a product versus quality of a process. Now as far as the first view is concerned, where we are talking about materials, component and systems, what are the materials that we use at site? It could be cement, steel, concrete, pre-stressing tendons, and the list goes on and on and on. So each of these materials must conform to certain quality standards, and that is what we are talking about when we say that we are talking about quality control of materials that are contributing to a construction project. Moving on, there are components of a structure. It could be beams, slabs, columns, walls. All of them as components, they are made of materials, but there is also a lot of other things that goes into making them. The form work, the compaction of concrete, the welding if it is involved and so on. Then there is the system. Finally, it is the system that is the target. The bridge, a building, a factory, a road, a sewer line and so on. The system is the final product. Moving this way, if we go, in order to ensure that the system performs acceptably, it's important that the components perform satisfactorily, and it's important that the materials perform satisfactorily. So there have to be benchmarks for materials, components, and systems, and that is what is ensured when we talk of quality control and quality assurance in construction projects. Now, coming to products versus processes as far as construction industry is concerned, products could be sleepers, pipes, girders, and so on, which are largely factory-made products. So in this day and age, we are talking about prefabricated members. Now, no matter how much prefabrication we do, we will be able to make certain products, but finally they'll have to be integrated at site to develop a system. We've often seen construction being done with precast girders. Now, those precast girders are factory-made products, but they have to be assembled, they have to be erected at site, and there's a lot of workmanship that goes on while they are at site in order to ensure that the bridge made with them meets the requirements. Coming to processes, there are so many processes. There could be welding, compaction, transportation of concrete, and so on. The list is endless. Each of these processes has to meet certain requirements. Only then will the products meet the requirements, only then the components will meet the requirements, and so on. So the whole gamut of thought process as far as construction industry is concerned from the point of view of quality is a very complex situation, and it's important that we understand each and every detail of whatever small bit we are looking at, and that will be the approach that we will adopt as far as this discussion is concerned in this course. Now, the thought process of quality control is closely linked to standardized methods and specifications. Test methods lay down a detailed procedure for almost all the steps involved in a test, especially for steps that are considered important from the point of view of results. We'll see this when we briefly talk about the parameters which are important from the point of view of testing the strength of concrete today, and later on in a subsequent discussion greater details. Engineers in the field are sometimes required to interpret the provisions in a method or create a new test method itself for a unique situation, and this adaptation or modification that an engineer makes cannot be arbitrary and must be based on principles of known and relevant tests and the required performance of the produce or the process. We'll appreciate the import of these statements better when we look at some of the examples. And now the purpose of these tests could be to ascertain the performance of a product or a process and determine its acceptability, or it could be simply to compare two products or processes. Issues relating to quality control will be examined using case studies or taking up examples of simple processes from the field. And the effort will be to carry out exercises that help in understanding the issues involved and how they are addressed in a quality assurance, quality control framework. So the discussion in this course is not so much about the provisions that exist, but what considerations must prevail or may have prevailed when we introduced those provisions in a particular test method or a specification. Now, to recapitulate, major quality control methods involve standardization, inspection, sampling, testing, acceptance, and remedial measures in the event that acceptance criteria is not readily met. These are things which should be addressed in our procedures, and only then we'll be able to talk about a proper quality control, quality assurance program, and also have fewer disputes, and that's something which we'll talk about later. We'll take up and discuss some specific issues from the construction industry and look at it